Hi there, I'm Nehemiah from Special Science class. We're looking at the introduction to General Chemistry 1. Why do we call it Introduction to General Chemistry 1? Because we have subsequent classes on Introduction to General Chemistry 001, 002, 003 until 1. Why do we do it like that? The reason is that a lot of students says chemistry is hard, chemistry is difficult. I don't want to study chemistry because they find chemistry difficult to understand. Well, the problem with these people or these folks is that they go ahead to study higher concepts of chemistry, like the inorganic chemistry, without understanding the general chemistry. And they go about studying the industrial chemistry, the physical chemistry, the organic chemistry, without understanding, or they study even other branches of chemistry without understanding the concept of general chemistry. And the concept of general chemistry will be given to you layers by layers. We're not going to give you higher concepts of it because we still have higher concepts of general chemistry. So what we're going to do in this video is to give you poco, little by little, things that you ought to know. And we don't want to give you a lot of chemistry gibberish. So stay with us. We're going to make chemistry easy as possible for all of you. Now, we're looking at definition first of all. What's the definition of chemistry? We can say that chemistry is a science that studies matter. So chemistry is a science that deals with matter. So if chemistry is a science that studies matter, and in chemistry, we call matter substances. So chemistry is a science that deals with substance. So in chemistry, we call matter substance. There are other science subjects like biology, like physics. This subject like biology deals with matter. Physics also deals with matter, but biology is dealing with living organism, living matter. And then physics is dealing with calculation, measurement, with the use of physical quantity like velocity, acceleration, mass, force, momentum, impulse. They are using physical quantity to measure the exact value of matter. But in all sense, physics, chemistry, and biology deals with matter, but chemistry deals with the own aspects of matter known as the properties of matter and the reaction of matter. So let's focus on the one of chemistry. It deals with the properties of matter and the behavior of matter. So we have the properties here now. Properties of matter, behavior of matter. Then if you want to classify or define the three: biology, science that studies living matter; physics, science that studies the measurement to give exact value using physical quantities for matter; chemistry, the science that studies matter, properties of matter, and the behavior of matter. I take it again. If you can understand these three triangular concepts here: chemistry studies matter, the properties of matter, and then the behavior of matter, then we want to know what this is all about. Now, for properties of matter, we have two properties of matter. So let's put it there. So the major two properties of matter is the physical properties, and we have the chemical properties. Now, if they were talking about the physical properties of matter, it answers the question what? Physical properties of matter answer the question what? And then the chemical properties of matter answers the question why. So it answers the question why. So the behavioral aspect of matter answers the question if. So we have if there. All right. Now when you're talking about what in the physical properties of matter, you're actually asking us what is this matter all about? When there is no change in the state of that matter, of that substance. You look at that substance, look at the color of the substance, you look at the boiling point of the substance, you look at the melting point of the substance. In case you're writing down, let me take it again. You look at the color of the substance, you look at the melting point of the substance, have you written that? You look at the boiling point of the substance, you look at the texture of that substance, you look at the solubility of that substance. Check it again: boiling point, melting point, color, texture, solubility of that substance. You even go to look at the spectroscopic properties, that is the IR, UV, NMR. Now, meanwhile, for the physical properties of matter, you also know that it's going to talk about there is no change. Now, no change is here. We use this triangle to represent change. In mass or in physics, whenever you see a triangle like this, it represents change in the state of something. So, no change. But over here, there is a change. Chemical properties, yes, there is a change. Now, over the other side, there is change or there is no change. I'm going to explain that now. Yes or no change. Now, what does that mean? Now, in these physical properties, it's telling us the state of the matter at a moment when there is no change in that matter or in that substance. Now, the chemical properties of matter is telling us the things that occur when there is a change in that matter, when new substance are formed. Now, for the behavior, it's telling us something about what will happen. The behavioral, the disposition or the behavioral attribute of that substance. Sometimes you look at the gaseous change when there's a reaction, gaseous change. Sometimes if the reaction is being occurred, if the reaction occurs, you'll find the color of the substance changing. You'll find the precipitate, white precipitate, or gelatinous white precipitate or blue precipitate coming out from the solution. That is the behavior of that substance. But meanwhile, the example of this chemical substance, which I notice I've not given to you, is flammability. The flammability or the ability of that substance to burn, to combust. Now, we'll talk about, we'll talk about the rusting of iron. That's a chemical change. We'll talk about the burning of wood. Many a times before I start studying, or when I started studying chemistry new, I thought that burning of wood is a physical change, but it's a chemical change. Why? Because the reaction, to reverse the reaction is not easy. You know, a chemical change, the reactions produce new substances. We have a log of wood, and you put fire in it, and then the wood turns to ashes, which is a change from the wood stage to the ashes state through combustion. And then I talk about rusting of iron. And you talk about souring of milk. All those things are chemical change. Now, we want to talk about matter in its whole, or in its entirety. So, matter is composed of different components. We have the atoms, we have the elements, we have the molecules, we have the compound, and we have the matter. Of course, we have the matter. Now, if you have this understanding that matter has atoms, it has elements, it has molecules, it has compound, it has matter. We're not going to give you chemistry gibberish. We're going to make the concept as easy as possible by giving you the meaning of all of those on the board. So let's pick up the first one. Let's deal with atom. Let's spin up the board so we can deal with atom. So, what's the meaning of the concept or the name atom? The name atom comes from the word atomus. And then the English word is smallest. So the name atom comes from the word atomus, and the English word means smallest. You can notice the arrangement here that atom is the first thing there. And inside that atom, necessarily, there are subatomic particles, which we're going to be looking at in a nutshell. Now, if you look at this atom, what's the definition of atom? If you look at the word smallest, you cannot say that atom is the smallest particle of an element. Of course, of an element. Of a matter, but mostly of an element. Atom is the smallest particle of an element. Why? If you say of a matter, the smallest particle of a substance, which chemists call matter, can be compound, can be molecule, can be element. Now, but if you talk about element, which is closer to atom, so you can easily say that atom is the smallest, and not just smallest, but indivisible. Because when you get to the state of atom, that matter or that substance cannot be divided again. So atom is the smallest particle of an element. I want to find a way to define it so that you can understand if this is the first time you're studying chemistry. If you look at a substance, you look at maybe a material, and you try to cut that material into small pieces, and you find a particular pieces of the material that cannot be divided, you call that particular pieces of that material atom of that particular material. So we're talking about atom of an element, which is the smallest indivisible, cannot be divided, smallest indivisible particle of an element. So that's the definition there. So let's take up the structure of an atom. The structure of an atom looks something like this. So we have 1, we have 2, and then we have 3. Now, if you look at the structure which we just gave on the board, which is the structure of an atom, there is a ball in it. There's a ball-like structure in it. And that ball-like structure is what we call nucleus. So we have, this is the nucleus of the atom. Let me change my pen. I don't like the way this is written. Then this is the orbit, or the shell. Now, revolving around the orbit or the shell of this atom is what we call electrons. So, electrons. We call this one electrons. And electrons is negatively charged. Electrons are negatively charged. So it has a negative charge over there. So electrons are negatively charged. So I told you that we're going to talk about subatomic particles in a nutshell. That's what I'm talking about. When you get to atom, after defining it, that is the smallest indivisible particle of an element, there are some subatomic charges in it. Now, those charges are electrons. Now, this is the structure of an atom. No one has seen an atom anyhow, but by scientific discovery, we can model the structure of an atom. So this structure is what we have in most of your textbook, all of your textbook necessarily. Now, if you look at this structure, in this structure, simple structure, if you follow the way I do it, you can do your own. And we have electrons, which is negatively charged. We have orbit and shell, which the electron is resolving round about 8. So in the nucleus of this atom, we have a positive charge and a negative and a neutral charge. Let's use the red pen for the positive charge, and let's use the blue for the negative negative charge. Now, for this one, which is proton, and for this one, which is neutron. Now, the proton is positively charged, so let's put the charge positive. Please don't mistake the two. Let me just make it so plain so that they will not confuse the both of them. So let's take it poco, little by little. So let's take it to the side. So we have neutron. And the neutron has a zero charge, or a neutral charge. If you understand this concept, sorry for that, if you understand this concept that there is inside the nucleus of an atom, proton and neutron. For instance, you will have an exam question that will ask you dash and dash, what and what can be found in the nucleus of an atom. It is proton and neutron. Proton and neutron. If you look at the board very well, you'll find proton, you'll find neutron. They are found inside the nucleus of an atom. What is found at the orbit of an atom is electron. What's the charge of electron? Negative. They can ask you what's the charge of electron in the exam? Negative. What's the charge of proton? Positive. What's the charge of neutron? Is zero, or neutral charge. These are things you need to know about an atom. Then you also need to know that the combination of proton and neutron is going to give you what we call mass number. So mass number is different from atomic mass and atomic weight. Well, that's not the concept for today's class, but just understand that mass number, atomic mass, atomic weight is not the same thing. We have a video for that to explain that for you. Now, we'll go to the next thing, which is molecules. Elements. So let's look at the concept of elements. What's an element? Over here, we have it. Elements. Now, if you're asked what's an element, you say simply that element is a pure substance. Element is a pure substance that is made up of just one kind of atom. I take it again. Element is a pure substance that is made up of just one kind of atom. You can put a full stop there. You're still correct. But let me tell you, you can have other features of element added to your definition. For instance, element is a pure substance that is made up of one kind of atom and cannot be broken down into simpler substance by ordinary chemical process. You see that you have three definitions. There is a pure substance. One is made up of just one kind of atom. If you look at the periodic table where you have the elements on the chart of the periodic table, you'll find out that each element exists alone, one of those elements. Now, those elements are known, sorry for that, those elements are known as pure substance because they exist alone and they are capable of independent existence, that's that, and they are also capable of chemical reactions. And meanwhile, also, they are also kind of not be able to be broken down into simpler substance by ordinary chemical means. So forgive us for that interruptions. And now, I lost my voice in so many of the classes we're running, so just forgive me for that. Now, we have elements. So this is an example of elements. So in the elements, we have the atomic mass. And then we have the atomic number. Now, I told you that atomic mass number, atomic mass, or atomic weight is not the same thing. But that's not the concept of today's class. We want to take everything poco, little by little, and then you understand. So if you want to understand that mass number, atomic mass, and atomic weight, you need to go to one of the subsequent videos of Introduction to Chemistry 001, 002. You're going to find that there. But this is Introduction to Chemistry 1, General Chemistry 1. Now, if you look at this concept, let's give you an example of an element. Let's say we have an element of sodium. If you look at an element of sodium, of course, if you want to study chemistry, another concept, another thing I would advise you to do is to go and learn 1 to 20 elements at least, or 1 to 30 elements mostly. I tell my students, don't learn 1 to 20 elements. That's not too good. It's good, but not too good. You can learn 1 to 30 elements. And we're going to tell you how to do that without having to consult your textbook. You have to recite it using an acronym from one of our subsequent videos of 001, 002 of Introduction to Chemistry. But let's just come back here. Just know this is an element of sodium. It has the atomic number 11 and a mass number 23. So that's sodium. Then for chlorine, we can have an element of chlorine has an atomic number 17 and a mass number 35. But meanwhile, chlorine can exist as an isotope. We can have another one that has different atomic number, same atomic number, sorry, because isotopes are elements that have same atomic number but different mass numbers. But meanwhile, that's not the concept for today's class. We also have that in another video, but just let's take it poco. Let's not give you a lot of chemistry gibberish in one video, because we are told and we know that too much information will lead to loss of memory. We have so much thing to learn just in one video. You can forget the whole important information that is in a video. So let's take it little by little. No chemistry gibberish, no lots of information, just little by little, and then we'll build on our concept to understand higher chemistry. So we have this sodium element, which has this is an atomic number. In case you see a sodium element and you want to identify atomic number, this one is atomic number, this one is atomic mass, this atomic number, this atomic mass. That's how to notice or identify those. So if we have done that, X means any element, and your work is to go and know the 1 to 20 or 30 elements at most, so necessarily you need to know that. Now, we're going to the next thing, which is molecules. So, what's a molecule? Don't forget the definition of elements. You can define that. If you have not written it down, it's a pure substance that is capable of independent existence and cannot be broken down into simpler substance by ordinary chemical means. So what's a molecule? A molecule are two or more elements that are chemically bound together. A molecule are two or more elements now that are chemically bound together. You can see the sequence of the arrangement. After atom, element, after element, molecules. Molecules are two or more atoms that are chemically bound together. And we have, for instance, take note of that. We have the monoatomic, monoatomic molecules. Those monoatomic molecules, note them, they are found in the group 8 or group 0 of the periodic table. I'm going to tell you what I mean by that. We have neon, we have argon, and we have helium. Why are they called monoatomic monoatomic molecules? Because they are just one. Let me write this very well so you can see it. So it's just one of those. Neon, just one of those. Argon, just one of those. Helium, just one of those. That's why it's called a monoatomic molecule. But meanwhile, we are told that molecules are elements, two or more elements that are chemically bound together. So we can call this molecule because they are inactive. This is octet. This is octet. This is duet. Octet means the electric configuration is 8 outside the shell, which means it is stable. It cannot react. The same thing with this. This one is duet, which is 2. And when an element has an outer electronic shell that is 2, it means the element is stable, which is duet. If the outer electronic shell is 8, that means the element is stable, which is octet. Now, that element cannot react because they are stable. Now, understand that. Let's come back to the board. But let's have diatomic, we have diatomic molecules. Atomic molecules like the chlorine. Why is chlorine called a diatomic molecule? Because it exists in 2. Now, we have another one. We have the oxygen is also a diatomic molecule. Why? Because it exists in 2. And then we have other ones. We have hydrogen. That's a diatomic molecule. Why? Di, 2, tri, pre, tetra, 4. So this is monoatomic molecule, 1. Diatomic molecule, 2. You understand that? Now, we now go to the concept of compound. So what's a compound? Meanwhile, we can have carbon dioxide. We can have water as a molecule. Now, this is made up of not just one type of atom. We have carbon, we have oxygen, we have hydrogen, we have oxygen. They are also known as molecule. Why are they called molecule? The difference between molecule and compound is that molecule is a combination of 2 or more elements which are chemically bound together. But the major difference there is that molecule is formed by covalent bonding, non-metal to non-metal, or dative bonding or coordinate covalent bonding, which when you go to chemical bonding, you are going to find that there. We're going to give it to you in a subsequent video too, so just stay with us. Now, but this one is formed by ionic bonding. The compound has two different charges, two different charged elements combined together. Let me show you what I mean by that. So let's go to compound. So what's a compound? Now, these compounds are pure substance that are combined together, 2 or more pure substance that are combined together in a definite proportion. For instance, if you look at a compound like sodium, I'm going to tell you why it's a compound, like sodium hydroxide, sorry, this is not sodium, that's sodium chloride. Sodium chloride. So now over here we have 2 elements. We have sodium, we have chlorine. But sodium is positively charged and chlorine is negatively charged. That's why it's called a compound. A compound has 2 elements that have different charges and they are combined in a definite proportion. Now we have sodium, which is positively charged, of course, hydroxyl. This is called hydroxyl. which is negatively charged. Then we have hydrogen, positively charged, and chlorine, which is negatively charged. You can notice that there are two different charges here, where if you come here, it's just one single charge that made up all those that are there. So if you can understand that compound is different from molecule by following the previous definition I gave to you, then you will know that these things are easy anyway or anyhow. So let's come to the last one, which is matter. I want to remind you that if you are having problem in knowing what's the formula of element, what's the compound name, element name, there's a video for that. So let's look at matter. Matter is a substance, or matter is a stuff. Matter is anything that has mass and occupies space. Not the word I use, mass, not width. Matter does not have width, it has mass and it occupies space. So we have this triangle, which is the face of matter. We have solid, we have liquid, and we have gas. Matter exists in three phases: solid, liquid, and gas. So this is all we've got for you, because too much information will lead to loss of memory or confusion. So we just have you to study this, go over it again and again, watch the video over and over again, and get the concept and start building your interest in chemistry, so you can understand other aspects and higher concepts of chemistry. Thank you very much for watching. I'll see all of you in the next class. Bye for now.